Let us start our discussion once again with the screening effect or shielding effect. So, discussing something about shielding effect, or the other thing that we were doing were screening effect. So what did I tell you in the last class? It was something like there is this nucleus which is there in the center and it is having lots of positive charges or protons, right? And now we do consider that there is an outermost electron which is lying somewhere here. So I told you if there were no inner lying electrons, then the nucleus would have completely attracted the outermost electron very, very efficiently. So there would have been a very cool interaction between the nucleus and the outermost electron, right? So now if I consider that case, the charge which is experienced by the electron would have been written as Z. Let's say the atomic number of nucleus, the atomic number of the atom that we will be considering is Z. So if the atomic number of the atom that we will be considering is Z, you can say that the positive charge on nucleus, the positive charge on nucleus will be Z times into charge on one electron, right? But then it has to be positive charge because the protons are having a charge which is equal but opposite in sign to that of the charge on electron. Am I right? So now can you say what is a charge experienced? So instead of saying what is a charge experienced, I should have written the charge that should be experienced by the outermost electron. So these two we have done. Now we were to find out the charge that should be experienced by the outermost electron. Let us say that charge should be Z, okay? Now see, because of the inner lying electrons, let's say, so 2 electrons were here, 1, 2, 3, 4 and so on, 8 electrons were there in the second shell, 6, 7, 8 electrons were there in the third shell, fourth and so on, so on, so on. Right? So because of the inner lying electron, the outermost electron will now not be able to experience the complete charge of the nucleus, right? So let us now introduce a constant which is screening constant. So this screening constant is also known by the name as the shielding constant. So let us say I am just representing it by the symbol sigma. Okay, so what is sigma or what is shielding or screening constant? So it is the tendency, or you can say it is the potential so that the electrons can be screened from the positive charge of the nucleus, right? So this is the extent of shielding. Okay. Now, if the electron was supposed to experience a total charge of Z, but some charge is getting shielded. So, what is the effective charge that is experienced by the electron? So, we call it as effective charge experienced by the electron. So the effective charge experienced by the electron will also be known as effective nuclear charge. So the effective charge experienced by the outermost electron will be effective nuclear charge, and this can be written as Z effective. So Z effective can be written as the actual charge on the nucleus minus sigma, which is screening constant. Okay, so finally we will end up the discussion here that Z effective will be Z minus sigma. Clear enough? For sure sigma will be greater than 1. So if the value of sigma will be greater than 1, then you can say the value of Z effective will be lesser than the value of Z. So the effective nuclear charge experienced by the outermost electron will be somewhat lesser compared to the nuclear charge on the nucleus itself. Okay. So now moving further, I will be telling you that this sigma value has been found to be different for that of S electrons, and it has been found to be different for P electrons, D electrons and F electrons. Okay. One another thing that I want you to remember very carefully is that if this is the nucleus, okay, and this I told you in the last class also, and the nucleus is quite small, fine, then the electrons which are lying close to the nucleus can form a very effective shield. So they will be having a very nice value of sigma. Okay. However, if the nucleus would have been bulky, okay, and now if I am trying to make a shield, then the electron density is not that much enough to shield the positive charge of the nucleus. So the sigma value of such electrons will be less. Okay, so this screening effect is basically helpful in the case of smaller atoms and not in the case of bulkier or larger atoms. Okay, now listen to me for one another minute. Okay. Now see, I am saying that we have done the electrons are there in orbitals, right? So what were orbitals? Then you know, right, that the orbitals are nothing but the three-dimensional space where the probability to find the electron is maximum. So three-dimensional space where the probability to find the electron is maximum. Right? So it is the three-dimensional space where the probability to find the electron has been found to be maximum. This is what is known as orbital. And from the discussion that we had in previous chapter in the atomic structure, we know that there are different kind of orbitals which are present. We have s orbital, which is basically spherical. Right? Then we have p orbital, we have d orbital and f orbital. So I told you this d actually stands for diffused. Right? So see, listen carefully. If I am talking about the electrons which belong to either s orbital or p orbital, then these electrons will have a very high electron density. Now what is electron density? Electron density is basically defined as number of electrons per unit volume in which the electrons are present. So if I am talking about the electron density of s and p orbitals,